Hello, today I'll be covering questions 5 and 6 of round 128 for the grade 8 and under Prairie Mathly problems. So I'm just going to share my screen and then get started. Okay, first question, or question 5, is that there's 8 identical cubes of size 1 by 1 by 1, and they all have the numbers 1 through 6 written on their faces, and 1 is written opposite to 2. So I'll just make a note of that. 3 is written on the opposite of 5, and 4 is written on the opposite of 6. And these cubes are stacked into a 2 by 2 by 2 cube. So it would look like something like this. Right, and all of the numbers appearing on the outer surface of the new cube will be added. So m is the maximum and then n is the minimum. Okay, each cube shows 3 faces. This means that let's start with the maximum. We have to find the maximum sum that 3 faces can make. And we have to follow these rules too. So if we can just take the largest numbers on this side, you'll find that the maximum sum on each face with 3 of the faces showing is just 2 plus 5 plus 6, which is 13. There's 8 cubes, so it's 13 times 8, which is equivalent to 104. And then we look at the minimum, which is just this side. So the minimum is 1 plus 3 plus 4, which is 8 for each cube. 8 times 8 is equal to 64. You subtract that, 104 minus 64 is equal to 40. Thus the answer is C, which is 40. Okay, this question states, moving horizontally and vertically from point to point along the lines in a diagram below, how many routes are there from point A to point B, which consists of 6 horizontal moves and 6 vertical moves? Okay, because this question asks like only 6 horizontal moves and only 6 vertical moves, this means several things. It means that you can't double back, right? You have to keep going. You can't just like come back, which actually makes this question drastically easier. So firstly, let's look at the bottom line. Let's see how many ways it is possible to get to each of these vertices. So there's only one way to get to this vertex. And there's also one way to get to this one, and one, and one, and one, and one. And this is because you can only go in straight lines, right? You can't double back or go down because that would just essentially extend the amount, like go over 6 moves that is allotted for the vertical and the horizontal. Okay, and then this vertex is also 1, right? Like you can only do that. So actually, you'll find that the amount of paths to get to each vertex is just the sum of the amount of paths needed to get to the 2 before it. So this one, there's 2 ways to get to it, and this vertex is also 2 ways because it's just only leading from 2 to this 2. So that's 2 and 2. And then this one is 3 because it's 2 plus 1. This one is 5 because it's 2 plus 3 here. And then this is also 5 because there's only one way up to this vertex, and the one way up has 5 paths that can get to it, right? And then if we follow the same logic, then, well, this one here is 4 because it's 3 plus 1. This is 9. You add this, that's 14. And then that's 5 and 6 and 14 and 28 and 20 and 48. And this one's still 14. 14 plus 28 is 42. 42 plus 48 is, well, you'll see that that's actually 80. Well, actually, no, that's 90, sorry. 90, and then 42 to 42. 90 plus 42 is 132. And this is still 132. So then the answer is B. Okay, thank you for watching. Bye.